March 24, 1945. 0200 hours. The Rhine Valley. Hauptmann Klaus Weber pressed his field glasses against the concrete slit of his observation bunker. The night air carried an unusual stillness, broken only by the distant rumble of engines across the river. His breath formed small clouds in the cold German spring air as he scanned the Allied positions through the darkness. Weber had commanded artillery batteries for 3 years. He understood the mathematics of death, trajectory calculations, charge weights, the precise timing needed to bracket enemy positions. His 105mm howitzers had spoken their language of destruction across Russia, Italy, and now the Reich's final barrier. But nothing in his training had prepared him for what came next. The first sound wasn't the whistle of incoming shells. It was deeper, a rolling thunder that seemed to rise from the earth itself, as if the planet was tearing apart at its seams. Weber's hands trembled against his binoculars, not from cold, but from a vibration that penetrated bone and sinew. Then, the horizon erupted. The 240mm shells arrived like meteorites, each one a concentrated piece of American industrial might weighing 360 pounds. The ground beneath Weber's feet shuddered with each impact, dust cascading from the bunker ceiling as the thunder grew closer. This wasn't artillery fire as he knew it. This was the sound of an entire nation's factory system focused into instruments of annihilation. Weber would survive the next 6 hours, but the artillery officer who emerged from that bunker would carry a different understanding of warfare, one written in the language of industrial terror. The evolution of artillery warfare from 1939 to 1943 had followed familiar patterns that German officers like Weber understood intimately. Artillery remained, as Napoleon had declared, the god of war, but it operated within predictable parameters. Guns were positioned, coordinates calculated, and firepower applied with mathematical precision. German artillery doctrine emphasized mobility, accuracy, and integration with advancing forces. The Wehrmacht's early victories had been built on this foundation. Coordinated artillery, infantry armor assaults that shattered enemy lines through concentrated firepower at decisive points. German 105 and 150mm howitzers, supported by the fearsome 88mm guns, had proven devastatingly effective across Poland, France, and the early Russian campaigns. The German Artillery Officer Corps represented the elite of military mathematics. These men had studied at the finest military academies, mastering ballistics tables, weather corrections, and fire control procedures that could place shells within meters of intended targets. They understood their weapons' capabilities intimately. The 105mm howitzer could deliver a 14.8-kilogram shell to ranges exceeding 10,500 meters, while the heavier 15-centimeter SFH-18 could hurl 43-kilogram projectiles over 13,000 meters. By 1943, German artillery had evolved into a sophisticated system. Forward observers called in coordinates through field telephones or radio sets, while battery commanders calculated firing solutions using mechanical computers and detailed firing tables. Counter-battery radar allowed German gunners to locate enemy artillery positions within minutes of their first shots. The system worked with Prussian efficiency, turning the chaos of battle into manageable mathematical problems. But mathematical problems required adequate resources to solve, and those resources were becoming scarce. Shell production couldn't match consumption rates. Quality control and ammunition factories suffered as skilled workers were conscripted or replaced by forced laborers. The tungsten needed for armor-piercing cores became increasingly difficult to obtain, while copper for shell-driving bands grew scarce. More troubling were reports filtering back from the Eastern Front about Soviet artillery concentrations. Red Army gunners were massing hundreds of pieces for single operations, creating barrages that lasted hours rather than minutes. German artillery officers who survived these bombardments described something beyond conventional artillery fire, a sustained industrial process that transformed entire grid squares into moonscapes. Yet even these reports couldn't prepare the Wehrmacht for what was developing across the Atlantic. While German factories struggled to maintain production of conventional artillery pieces and ammunition, American industry was scaling up to levels that defied European comprehension. The arsenal of democracy wasn't just producing more guns, it was creating entirely new categories of firepower. The numbers told a story that few German officers fully grasped in 1943. American factories were producing artillery shells at rates exceeding 100,000 rounds per day. Steel production had increased by 300% since 1940. The Chrysler tank arsenal alone could manufacture more armored vehicles in a month than some German factories produced in a year. This wasn't just quantitative superiority. It represented a fundamental transformation in the nature of warfare. The 240mm howitzer represented the pinnacle of American artillery engineering, a weapon that embodied the industrial philosophy that would define the final years of the war. Designated the M1, this massive gun could hurl 360-pound shells to distances exceeding 23,000 meters, nearly 3 times the range of standard German field artillery. Development of the 240mm howitzer had begun in 1941 when American ordnance engineers recognized that conventional artillery would be insufficient against German fortifications. The weapon that emerged from this requirement stood 8 feet tall and weighed 64,700 pounds in firing position. Its barrel alone measured over 27 feet in length, machined to tolerances that ensured devastating accuracy at extreme ranges. But the howitzer itself was only one component of an integrated industrial system. Each 240mm shell required 88 pounds of high explosive, precision manufactured in American chemical plants that operated around the clock. The brass cartridge cases demanded copper from mines across the American West, while the steel shell bodies emerged from foundries in Pittsburgh and Gary. Even the wooden shipping crates were produced by lumber mills that had retooled specifically for military production. Transportation of these weapons required specially designed tractors and trailers, manufactured by companies that had previously built commercial trucks. The M5 high-speed tractor, weighing 38,000 pounds fully loaded, could tow a 240mm howitzer at speeds up to 35 miles per hour across improved roads. This mobility allowed American artillery commanders to concentrate massive firepower wherever needed, then redeploy rapidly to new positions. Training crews for these weapons demanded a different approach than traditional artillery instruction. Operating a 240mm howitzer required 12 men working in precise coordination. Loading the 360-pound shells required mechanical hoists and hydraulic systems. Fire control computations involved ballistic calculations beyond the scope of conventional field artillery. The United States Army established specialized schools where crews spent months mastering these complex weapon systems. By early 1944, American industry was producing 240mm howitzers at rates that would have seemed impossible 2 years earlier. The Watervliet Arsenal in New York manufactured the barrels using precision boring techniques developed for naval guns. Meanwhile, ammunition production reached industrial scales. American factories delivered over 50,000 240mm shells during the first quarter of 1944 alone. This production capacity enabled tactical employment that transcended traditional artillery doctrine. Rather than dispersing guns across the battlefield for general support, American commanders could mass dozens of 240mm howitzers for specific operations. The psychological effect of sustained bombardment from these weapons extended far beyond their physical destructive power.
Intelligence reports reaching German headquarters described American artillery parks containing hundreds of pieces, with supply stockpiles that measured in thousands of tons. These weren't temporary concentrations for specific battles. They represented permanent capability, sustained by supply chains that stretched back to the industrial heartland of North America. German artillery officers reading these reports faced a troubling realization. Their mathematical approach to warfare assumed roughly equivalent resources on both sides. Fire missions were planned based on available ammunition. Battery positions were selected, considering the need to conserve scarce shells. Counter-battery fire was calculated to achieve maximum effect with minimum expenditure. But American artillery doctrine operated from completely different assumptions. Ammunition was abundant enough to sustain hours-long bombardments.
Shells could be expended freely for registration fire, harassment missions, and suppressive barrages. The industrial base could replace any losses within weeks rather than months. This transformation in warfare's fundamental economics would soon confront German artillery officers with tactical problems that had no solutions within their traditional framework.
Oberst Heinrich Zimmermann had graduated from the artillery school at Jüterbog in 1936, where instructors emphasized the cerebral nature of artillery command. Gunners are mathematicians in uniform, his professors had declared, teaching young officers to calculate firing solutions using slide rules and logarithmic tables. The battlefield was reduced to coordinates on a map, target acquisition to precise angular measurements. This intellectual approach served Zimmermann well through the Polish and French campaigns. His battery of 105mm howitzers could engage targets with mathematical precision, adjusting fire based on observed corrections and atmospheric conditions. The physics of projectile motion obeyed predictable laws, allowing skilled officers to place shells exactly where needed. But mathematical training hadn't prepared Zimmermann for the psychological impact of receiving industrial-scale bombardment. When Allied 240mm shells began falling around his command post near Caen in July 1944, the ground-shaking impacts triggered responses that transcended rational calculation. His hands shook uncontrollably as he attempted to plot coordinates. The slide rule became impossible to operate as each distant explosion sent vibrations through his body. The sound alone defied his experience. German artillery produced sharp cracks followed by whistling trajectories. The 240mm howitzers generated deep rolling thunder that seemed to emerge from the earth itself. Shell fragments weighing several pounds landed hundreds of meters from impact points, while the blast waves shattered windows and structures over a kilometer away. Zimmermann's carefully trained crew struggled to maintain their firing routine as Allied shells landed closer to their position. The precise timing required for effective battery fire dissolved under the stress of constant bombardment. Men who had operated their guns with clockwork efficiency began making computational errors, miscommunicating coordinates, and flinching at the controls during the firing sequence. The 240mm M1 howitzer represented a quantum leap in artillery technology that German intelligence services struggled to comprehend fully. Intelligence reports provided basic specifications, barrel length, shell weight, maximum range, but failed to convey the weapon's integrated technological sophistication. The howitzer's hydraulic recoil system absorbed the massive forces generated by firing 360-pound projectiles at muzzle velocities exceeding 700 meters per second. German engineers reading these specifications understood that such forces would destroy conventional artillery designs within dozens of rounds. The M1's ability to sustain hundreds of rounds without mechanical failure indicated manufacturing precision and metallurgical advances that exceeded German capabilities. Fire control systems integrated with the 240mm howitzer employed technologies that pushed beyond traditional artillery methods. American survey teams used precision instruments to establish firing positions accurate to within meters across distances of several kilometers.
Meteorological data was collected continuously and transmitted to fire direction centers where mechanical computers calculated firing solutions, accounting for wind speed, air density, and temperature variations. The shells themselves incorporated technological innovations that multiplied their destructive effect. Variable time fuses allowed 240mm projectiles to detonate at predetermined heights above target areas, creating airbursts that showered deadly fragments across wide zones. High explosive shells contained carefully formulated explosive compounds that generated blast pressures exceeding 10,000 pounds per square inch at close range. Communication systems linking forward observers to firing batteries operated through radio networks that maintained contact across distances of 20 kilometers or more. This allowed American artillery commanders to coordinate multiple batteries firing simultaneous missions, creating concentrated barrages that overwhelmed target areas with hundreds of shells arriving within minutes of each other. German technical intelligence teams examining captured 240mm shells found manufacturing quality that surpassed their own standards. Machine tolerances in the fuse mechanisms measured in thousandths of an inch. The steel used in shell construction showed uniform composition throughout, indicating quality control procedures that German factories couldn't match under wartime conditions. Most disturbing were the production markings found on captured ammunition. Serial numbers indicated that American factories were manufacturing 240mm shells in lots of thousands, with multiple production facilities contributing to overall output. The implications were staggering. American industry could sustain bombardments that would exhaust German ammunition reserves within days. German counter-battery doctrine had evolved through decades of careful study and battlefield experience. Locate enemy artillery through flash spotting, sound ranging, or aerial observation. Calculate firing solutions to neutralize the threat with minimum ammunition expenditure. Execute precise fire missions that destroyed enemy guns while conserving scarce German shells. This approach had proven effective against opponents operating under similar resource constraints. French artillery in 1940 could be suppressed by concentrated fire from a single German battery. Soviet guns in 1941 and 1942 were vulnerable to counter-battery fire because ammunition shortages forced Russian gunners to limit their firing rates. But American artillery operated from entirely different tactical assumptions that rendered German counter-battery doctrine ineffective. When 240mm howitzers opened fire, they did so from positions 20 kilometers or more behind the front lines, beyond the range of most German counter-battery weapons. The few German guns capable of reaching such distances lacked sufficient ammunition to sustain effective counter-battery missions. Even when German observers successfully located American artillery positions, the response they encountered defied conventional tactical logic. Instead of ceasing fire and relocating, American batteries often increased their firing rates, apparently unconcerned about ammunition consumption. Multiple batteries would engage the same target simultaneously, creating redundancy that ensured mission completion even if individual guns were suppressed. Major Rudolf Steiner commanded a counter-battery section equipped with 15-centimeter SFH-18 howitzers during the Normandy campaign. His mission was to locate and neutralize Allied artillery through precise fire missions using carefully rationed ammunition. Each German shell had to count. Ammunition resupply came irregularly, and every round fired reduced the battery's future capability. Steiner's first encounter with concentrated 240mm fire occurred during the Allied bombardment preceding Operation Cobra in July 1944. His sound-ranging equipment detected American artillery positions approximately 18 kilometers behind Allied lines, at the extreme range of his 15-centimeter howitzers. Following Doctrine, Steiner calculated a precise fire mission designed to neutralize the American battery with minimum ammunition expenditure. The German counter-battery fire landed accurately, with several shells impacting directly on the American position. Steiner's observers reported secondary explosions and smoke rising from the target area, indicating successful hits on ammunition stockpiles. Under normal circumstances, this would have eliminated the enemy battery and ended the threat. Instead, the American bombardment intensified.
Additional 240mm howitzers joined the fire mission, apparently summoned from other positions to replace any damaged guns. The volume of incoming fire doubled, then tripled as American commanders concentrated additional batteries on their targets. Steiner's mathematically precise counter-battery fire had triggered an industrial response that overwhelmed his defensive calculations.
General Major Kurt Hausser had commanded artillery formations since 1938, leading his units through successful campaigns across Europe. His leadership style emphasized calm analytical thinking, precise planning, and careful resource management. Artillery command required patience and mathematical precision rather than dramatic heroics. These leadership qualities served Hausser well during the Wehrmacht's victorious years when German artillery operated against opponents with similar technological capabilities and resource constraints. Fire missions could be planned deliberately, ammunition allocated carefully, and positions selected based on careful terrain analysis. But the intensity of Allied bombardment during the summer of 1944 created leadership challenges that transcended traditional military training. When 240mm shells began falling around his command post, Hausser faced immediate decisions that couldn't wait for careful analysis. Should his batteries remain in position and attempt to continue their fire missions, or should they displace immediately to avoid destruction? Traditional artillery doctrine suggested that well-constructed gun positions could withstand conventional bombardment long enough to complete assigned missions. But the 240mm howitzers created crater patterns that obliterated entire grid squares, making traditional defensive preparations inadequate. Hausser watched as carefully prepared positions were reduced to moonscapes within minutes of the bombardment's beginning. Communication with subordinate units became nearly impossible as telephone lines were severed by shell fragments and radio operators struggled to maintain contact through the electronic interference generated by continuous explosions. Hausser found himself commanding through instinct rather than information, making tactical decisions based on incomplete data and desperate improvisation. The psychological pressure on his subordinate commanders was equally severe. Battery commanders who had operated with methodical precision began making hasty decisions, displacing their guns prematurely or firing missions without proper coordination. The careful timing that made German artillery effective dissolved under the stress of sustained bombardment. Hausser realized that his leadership methods required fundamental adaptation. Rather than issuing detailed orders based on careful analysis, he needed to provide general guidance that allowed subordinate commanders to respond rapidly to changing conditions. The mathematical precision that had defined German artillery command gave way to improvised flexibility driven by survival instinct. Most troubling was the recognition that traditional military leadership principles, leading by example, maintaining calm under pressure, making rational decisions based on available information, were insufficient against an opponent whose industrial capacity rendered careful resource management irrelevant. American artillery commanders could afford to make mistakes because their ammunition supply was effectively unlimited. German officers faced tactical problems that had no solutions within conventional military framework. March 24, 1945, 0300 hours. Operation Plunder begins. Hauptmann Weber felt the first vibrations through the concrete floor of his observation bunker 30 seconds before the sound reached his ears. The mechanical precision of German timekeeping had trained him to notice such details. The difference between the arrival of pressure waves through solid earth and airborne sound waves traveling at 343 meters per second. The Allied artillery preparation for the Rhine crossing began with mathematical precision that Weber could appreciate professionally. The initial rounds were registration fire, single shells from different batteries, allowing American forward observers to adjust their coordinates for maximum accuracy. Weber watched through his periscope as colored smoke rounds marked reference points along the German defensive line. Then the mathematics transformed into industrial annihilation. At exactly 03:05 hours, over 3,000 Allied artillery pieces opened fire simultaneously. Weber's trained ear could distinguish the different calibers by their sound signatures: the sharp crack of 105mm howitzers, the deeper boom of 155mm guns, and underlying it all, the earth-shaking thunder of the 240mm monsters positioned far behind Allied lines. The first 240mm shell to land near Weber's position created a crater 12 meters across and 4 meters deep. The explosion generated a pressure wave that cracked the concrete walls of his bunker despite their 2-meter thickness. Dust cascaded from the ceiling as the structure shuddered under forces that exceeded its engineering specifications. Weber attempted to maintain his professional composure, reaching for his field telephone to report the bombardment to higher headquarters. The line was dead, severed by shell fragments that had sliced through communication cables buried 3 meters underground. His radio operator was pressed against the bunker wall, hands clamped over his ears, no longer able to function, as the concussive blasts made coherent thought impossible. The second 240mm shell landed closer, perhaps 50 meters from the bunker entrance. Weber felt the shock wave through his body, a physical force that seemed to squeeze his internal organs and left his ears ringing with a high-pitched tone that wouldn't fade. Through the observation slit, he could see his battery positions disappearing under direct hits that pulverized both guns and crews. By 03:15 hours, Weber understood that he was witnessing something beyond conventional warfare. The Allied bombardment wasn't designed to suppress his artillery. It was systematically obliterating every defensive position within a 20-kilometer zone. Shell fragments weighing several kilograms were landing hundreds of meters from impact points, while the continuous explosions created a rolling earthquake that made accurate observation impossible. His 105mm howitzers, positioned in carefully constructed emplacements, were being destroyed faster than their crews could abandon them. Weber watched through his periscope as a direct hit from a 240mm shell simply vaporized one of his guns, leaving only a smoking crater where the weapon and its 6-man crew had been positioned seconds earlier. The psychological impact transcended physical destruction. Weber had trained for 3 years to direct artillery fire under combat conditions, but nothing had prepared him for the sensory overload of sustained heavy bombardment. The continuous thunder made verbal communication impossible. The ground vibrations interfered with mechanical equipment. Even simple tasks like reading coordinates from a map became difficult as his hands shook uncontrollably. At 03:25 hours, a 240mm shell landed directly on Weber's ammunition storage bunker, located 200 meters behind his observation post. The secondary explosion of 500 stored artillery shells created a fireball that rose 100 meters into the night sky. The blast wave shattered the windows in buildings over a kilometer away and sent debris raining down across the entire defensive sector. Weber realized that his mathematical training, his careful study of ballistics and fire control procedures had become irrelevant. The Americans weren't solving tactical problems through precise application of firepower. They were using industrial capacity to eliminate problems entirely. Every German position within range was being systematically destroyed regardless of the ammunition cost.
Weber noticed the shift immediately. The firing pattern became more systematic, moving in a precise grid from east to west across the German defensive zone. This wasn't random destruction, but methodical obliteration, with each grid square receiving exactly the same treatment, regardless of whether it contained significant military targets. Through his cracked periscope, Weber observed American forward air controllers directing the bombardment using techniques that surpassed German fire control methods. Colored smoke rockets marked the boundaries of each target area, while radio communications coordinated the timing of multiple battery fires to ensure continuous coverage without gaps. The 240mm howitzers were now firing in coordinated salvos, 4 or 6 shells arriving simultaneously to create overlapping blast patterns that guaranteed destruction of anything within the target zone. Weber calculated that each salvo delivered over 2,000 pounds of high explosive to an area roughly 100 meters square. No defensive structure could survive such concentrated firepower. His own battery positions had been obliterated by 0340 hours, but the bombardment continued with mechanical precision. Weber realized that American artillery doctrine didn't depend on observing results or adjusting fire based on target destruction. The industrial capacity was sufficient to ensure complete obliteration through sheer volume of firepower. At 0350 hours, Weber heard a sound that chilled him more than the continuing explosions: the rumble of approaching tanks. Allied armor was beginning its advance while the artillery bombardment continued, coordinating the movement of ground forces with the systematic destruction of defensive positions. This coordination represented tactical sophistication that exceeded German capabilities. The Wehrmacht had never possessed sufficient artillery ammunition to sustain such intensive bombardments while simultaneously supporting advancing infantry and armor. German commanders were forced to choose between preparatory bombardment and close support for attacking forces. But American doctrine assumed unlimited ammunition supply, allowing artillery to perform multiple missions simultaneously. Some batteries continued the systematic destruction of German positions, while others shifted to close support missions, providing rolling barrages ahead of advancing infantry. The industrial capacity supported tactical flexibility the German forces couldn't match. Weber's telephone suddenly crackled to life. A communications section had managed to restore contact using emergency cables. The voice of his regimental commander reached him through static and interference, demanding a situation report and firing coordinates for counter-battery missions. Weber stared at his map, now covered with red marks indicating the locations of destroyed German positions. His artillery regiment had ceased to exist as an effective fighting force. Of 12 105mm howitzers under his command, 11 had been destroyed by direct hits from 240mm shells. The surviving gun had been abandoned by its crew, who had fled their position when a near miss buried the weapon under tons of displaced earth. "Herr Oberst," Weber reported through the crackling telephone connection, "we have no capability for counter-battery fire. Our positions have been eliminated." The silence on the other end of the line lasted several seconds before his commander's voice returned, now strained with disbelief. "Repeat your last transmission, Hauptmann." Weber stared at his map, now covered with red marks indicating the locations of destroyed German positions. His artillery regiment had ceased to exist as an effective fighting force. Of 12 105mm howitzers under his command, 11 had been destroyed by direct hits from 240mm shells. The surviving gun had been abandoned by its crew, who had fled their position when a near miss buried the weapon under tons of displaced earth. "Sir, the enemy has demonstrated industrial superiority that renders our counter-battery doctrine obsolete. We are not facing conventional artillery, but an industrial process designed to eliminate all defensive capability through overwhelming firepower expenditure." At 0400 hours, the bombardment ceased as suddenly as it had begun. The silence seemed unnatural after the continuous thunder of exploding shells.
Weber's ears continued ringing, but he could now hear the sound of Allied tanks and infantry advancing across ground that no longer contained effective German resistance. In those final minutes of darkness, Weber understood that he had witnessed the end of warfare as he had been trained to understand it. The careful mathematical calculations, the precise resource management, the tactical elegance of traditional artillery doctrine, all had been rendered irrelevant by an opponent whose industrial capacity could transform entire landscapes into wasteland within hours. Dawn revealed the scope of destruction that statistics could never convey. Weber emerged from his bunker into a landscape that bore no resemblance to the defensive positions his regiment had occupied 12 hours earlier. The mathematical precision of German military engineering had been erased by industrial mathematics of a different order. Crater analysis revealed the systematic nature of American fire distribution. Each 240mm shell had created blast patterns that overlapped with mathematical precision, ensuring no defensive structure could survive between impact points. Weber counted 17 major craters within 200 meters of his command post, indicating a density of firepower that exceeded any previous bombardment in military history. The casualty reports, when they could be compiled, told a story that transcended individual tragedy. Weber's artillery regiment had suffered 78% casualties in 47 minutes of bombardment. Most deaths had occurred instantaneously. Men vaporized by direct hits from 360-pound shells or killed by blast waves that liquefied internal organs without visible external wounds. Obergefreiter Hans Müller, a veteran gunlayer with 3 years of combat experience, could no longer read firing tables with his hands shaking uncontrollably. The mathematical relationships between range, elevation, and charge weight, knowledge that had been automatic for years, became confused and unreliable. His nervous system had been fundamentally altered by exposure to industrial-scale bombardment. Equipment losses exceeded personnel casualties in their strategic significance. German artillery production in early 1945 could replace perhaps 12 howitzers per month across all fronts. Weber's regiment had lost 11 guns in less than an hour, nearly a month of total German production eliminated by a single American fire mission. More critically, the specialized equipment required to operate artillery effectively had been destroyed along with the guns themselves. Fire control instruments, communication equipment, surveying tools, and mechanical computers represented manufacturing capacity that Germany could no longer replace. Each destroyed battery eliminated not just firepower, but the technological infrastructure required to apply that firepower effectively. American intelligence teams arrived within hours of the bombardment's conclusion, systematically photographing and cataloging the destruction. Weber watched from his bunker as enemy officers measured crater dimensions, collected fragments from German shells that had been destroyed in secondary explosions, and documented the effectiveness of their fire distribution patterns. The speed and thoroughness of this intelligence gathering indicated systematic study rather than casual battlefield assessment. American artillery doctrine was evolving through scientific analysis of bombardment results, using German defensive positions as experimental data to refine future fire missions. Resupply efforts revealed the broader implications of industrial-scale destruction. German logistics networks had been designed to support conventional ammunition consumption rates, perhaps 50 shells per gun per day during intensive operations. But replacing equipment destroyed by 240mm bombardments required resources that exceeded German production capacity by orders of magnitude. Transportation infrastructure had been systematically targeted during the bombardment,
with 240mm shells destroying road junctions, railway bridges, and supply depots located far behind the lines. American artillery doctrine recognized that disrupting logistics was as important as destroying combat units, an understanding enabled by ammunition abundance that allowed long-range interdiction missions.
The broader strategic implications became clear as similar reports arrived from artillery units across the Western Front. German artillery doctrine, refined through decades of military study and proven effective in earlier campaigns, had become obsolete within the span of a single military season. General Oberst Heinz Guderian, reviewing casualty reports from multiple artillery regiments, recognized that German counter-battery capabilities had been fundamentally compromised. The mathematical precision that had made German artillery effective required stable firing positions, adequate ammunition supplies, and predictable enemy behavior. American industrial capacity had eliminated all three prerequisites. Intelligence assessments revealed the scope of American artillery expansion. By March 1945, Allied forces possessed over 500 240mm howitzers in the European theater, with ammunition stockpiles exceeding 100,000 rounds. Production capacity could sustain bombardments of the intensity witnessed during Operation Plunder for months without straining American industrial output. German artillery officers who survived intensive 240mm bombardments required extensive retraining before they could resume effective command duties. Traditional fire control procedures had to be modified to account for the psychological effects of industrial-scale destruction. Officers who had operated with mathematical precision under conventional combat stress became unable to perform basic calculations after exposure to sustained heavy bombardment. Training doctrine required complete revision to address tactical realities that had not existed during the Wehrmacht's victorious years. New artillery officers had to be prepared for combat environments where enemy firepower superiority was absolute and sustained. Traditional emphasis on offensive fire missions gave way to survival training focused on concealment, rapid displacement, and psychological endurance. The material cost of adapting to American artillery superiority exceeded German industrial capacity. Effective counter-battery operations required guns capable of engaging targets at ranges exceeding 20 kilometers, specifications that German factories could no longer meet consistently. Even when suitable weapons could be manufactured, ammunition production remained inadequate to sustain operations against opponents whose shell expenditure was effectively unlimited. Medical services struggled to treat the unique injuries caused by 240mm bombardments. Traditional wound treatment assumed injuries from shell fragments weighing ounces or pounds. The 240mm shells produced fragments weighing 10 to 20 pounds, traveling at velocities that caused traumatic injuries beyond conventional medical experience. Psychological trauma from industrial-scale bombardment required treatment methods that German military medicine hadn't developed. Officers who had functioned effectively through years of conventional combat became unable to command artillery units after exposure to sustained 240mm fire. The mathematical thinking required for effective artillery command seemed particularly vulnerable to the sensory overload created by industrial bombardment. Communication systems required complete redesign to function during intensive bombardments. Traditional field telephone networks couldn't survive the systematic destruction created by 240mm fire missions. Radio equipment needed additional shielding to operate through the electronic interference generated by continuous explosions. Even basic visual signaling became impossible during bombardments that created continuous smoke and dust clouds. Supply doctrine had to account for consumption rates that exceeded traditional calculations. German logistics assumed that ammunition expenditure could be predicted based on tactical requirements and available supplies.
But defensive operations against American artillery required preparation for bombardments that could expend more shells in one day than German units had previously consumed in entire campaigns. The psychological impact on civilian populations exposed to 240mm bombardments created additional strategic complications. German propaganda had emphasized the Wehrmacht's ability to protect the homeland from enemy attack. Industrial-scale destruction of military positions demonstrated Allied capability to systematically obliterate any target within range, undermining civilian confidence in German defensive capabilities. By April 1945, German artillery doctrine acknowledged tactical realities that previous military theory had not anticipated. Enemy industrial superiority could create local firepower advantages so overwhelming that conventional military responses became inadequate. Survival, rather than tactical effectiveness, became the primary objective for German artillery units facing American bombardment. In the quiet aftermath of industrial thunder, Hauptmann Weber understood that he had witnessed more than a military defeat. The mathematics of destruction that had governed warfare since the invention of gunpowder had been superseded by the mathematics of mass production. Traditional military doctrine assumed roughly equivalent industrial capabilities among combatants. Artillery duels were fought between opponents operating under similar resource constraints, making tactical skill and professional competence the deciding factors. Weber had been trained in this world of mathematical precision, where each shell fired required careful calculation and every gun position demanded thoughtful consideration. But March 24, 1945, had demonstrated the emergence of warfare, where industrial capacity rendered tactical skill secondary to production capacity. American 240mm howitzers didn't represent superior military engineering. They embodied the application of automotive manufacturing techniques to the production of destruction. The same assembly line methods that produced civilian automobiles could manufacture artillery shells in quantities that overwhelmed any conceivable defense. This transformation extended beyond military affairs into fundamental questions about the nature of modern civilization. The industrial systems that created prosperity and comfort could be redirected toward annihilation with terrifying efficiency. The same technological sophistication that improved daily life could systematically eliminate entire armies through methodical application of overwhelming force. Weber had entered that bunker as a professional artillery officer, confident in his mathematical training and tactical competence. He emerged understanding that individual military skill had become irrelevant against opponents whose industrial systems could treat ammunition as an unlimited resource. The careful calculations that had defined his professional identity were meaningless against forces that could afford to solve tactical problems through brute application of overwhelming firepower. The sound of those 240mm shells would remain with him for the rest of his life, not just as memory, but as the echo of a transformation in human warfare. The thunder that had shaken his bunker represented the voice of industrial civilization applied to the ancient art of destruction. It was a sound that spoke of factories and assembly lines, of coordination between distant production centers and immediate tactical requirements, of mathematical precision applied not to individual targeting problems, but to the systematic elimination of entire defensive systems. In that terrible dawn, Weber had witnessed the future of warfare and understood that humanity's capacity for creation and destruction had merged into a single, overwhelming force that would reshape the world beyond recognition.
I hope you enjoyed this. If you'd like to see more stories from me, please like this video, subscribe to my channel, and leave a comment below. Turn on notifications by hitting the bell icon.